Okay, all right. So today we're going to talk about the third form of all the three linear functions, which is a standard form. So let's take a look. Okay, all right. I hope the sound is good actually, because this new mic that I got for the house is kind of on the quiet side. So, all right, okay. I'll adjust it accordingly later. All right, okay. So here we're talking about the third form. So what have we done so far, right? We've done slope intercept, which looks something like this, right? I give you the slope and I give you the y-intercept. We talked about the point slope form, right? Which is more problem specific, meaning if I give you a point and I give you a slope, can you give me the equation, right? We talked about graphing too, so we talk about the equations of graphing. So today we're going to talk about the third thing, which is what is a standard form, right? So this is a standard form. Now you should really write this down, okay? So this is the standard form. So this is the letter version, the generic version of a standard form, which is two things you really got to notice actually. One is we got the x and the y, right? Just like this has an x and a y, right? Nothing changes here. The other thing that I want to point your attention to is this. There are three letters here that are represented by numbers. So in this case, A, B, and C. So which is represented by 2, 3, and 12 respectively. Okay, so that's a standard form. Now, by this point in the unit, you might be wondering, hey, why do we have like three different forms, right? And as usual, the way I answer is because there are a couple reasons you need to know that. So let's take a look. So the first thing you need to know is that we can use it for graphing purposes. Meaning, if you don't have a calculator on hand, right, it's actually quite easy to draw this as a graph. So let me show you. So what was the original equation? 2x plus 3y equals 12. So let me rewrite that. So here, we could attack the problem from two different angles. The first thing is this, right? We can solve for the y-intercept. Now, that's not a new phenomenon for you guys. You got to know what y-intercept is. Now, think about that, right? Whenever we have a y-intercept, the point is always sitting on the y-axis, right? Which really also implies this, just as importantly. So I could put a point here, right, for the y-intercept. I could put a point here. I could put a point here. I could put a point here, so on and so forth, right? Have you noticed between all these points what they have in common? Yeah, the x is always 0, right? This is 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is 0, 8. This is 0, 2. This is 0, negative 3. This is 0, 1, 2, 3, 4, 5, 6, 7. This is 0, negative 7. And this is 0, negative 10. That in between all of these guys, the x is always 0. So what does that imply? If x were to be 0, right here, then we could know right off the bat what the y-intercept is, right? So let me erase this in preparation for the question. Okay, so right, so meaning, right, 2 times 0 is 0. I don't even need to write that, right? I can just write 3y equals 12. Divide both sides by 3. Y equals 4. So right off the bat, you know that the y-intercept is 0, 4. And let's plot that. 0, right, 1, 2, 3, 4. Right, I'll write it out, okay? Now, on the other hand, let me use a different color. I'll use red, okay? Let's say, right now, because you got to remember, how many points, what's the minimum amount of points you need in order to draw a straight line? Yeah, you need 2, right? So think about this. How are we going to get this other point? Yeah, just find the x-intercept, right? Now, this is a brand new concept to you, right? Because so far we've only talked about the Y-intercept, and we never really talked about the X-intercept, which is just, it's the same idea, right? Which is it's gonna be some point lying around on the X-axis, which means what? Yeah, Y is gonna be 0 this time, right? So look at this point, right? This is -1, -2, -3, -4, -5, -6, 0, right? This is -3, 0. This is 3, 0, so on and so forth. You get the point, right? All the Y values are 0 in this case. So same strategy. All we have to do then is to substitute Y with 0. So I'm going to keep my 2x plus 3 times 0 equals 12, right? So that becomes nothing. So that's 2x equals 12 divided both sides by 2, x equals 6. So here, the x-intercept, therefore, is 6, comma 0. Got that? So 1, 2, 3, 4, 5, 6 right here. And look, voila, right? We got our 2 points, and let's connect them. That didn't do a very good job there. Hold on, let me try to connect them some more. Much better. Okay, and there you have it. There we have our line. Look how fast that was, right? Because you don't, if you really wanted to, you can just substitute this in your head and you can solve it fairly quickly. Your 2 points and connect them. So it's a very quick and dirty way of getting a line when it's presented in this form. So one of the things that I want you to start understanding is with different forms, there are different quick ways of solving it. So remember with slope intercept form, what did I say? Let's go all the way back, all right, to before Thanksgiving, right? Slope intercept form. Right? Now, one is you can create a table of values, right? Or you can use a graphing calculator, which I will show you later on in this unit, right? And then with point slope form, right? We graphed it like this, right? You start off with a point and you just count boxes, right? Rise over run. And now this is the third way. The third way of graphing something very quickly using the standard form is by finding the x and the y-intercept, like so. Okay, and that's how you would do it. So right now what I'm going to do is this. Let me erase this and let you try the next one on your own. Okay, and when you come back, I'll show you the answer key because I want you to have a fairly thorough knowledge on how to do things like these. Okay, so hold on. So let me show you the equation. So this is the equation. So try this one right now, and when you come back, I'll show you the answer key along. I keep clicking on the wrong button. All right, so when you come back, I will show you the answer key. Okay, so press pause right now. Okay, all right, so here's what I did, right? Now, I think it might be good if you're always looking for the y-intercept first, because we learned that first. So what did I do? When I want the y-intercept, I have to substitute the x with a 0. Okay, remember that, all right? So I got 0, 4 is my point, right? And then when I want the x-intercept, I want y to be 0, right? So meaning if y wasn't moving, where would x be? Think of it like that, okay? And then I got 5, 0. I plotted the 2 points, connect them, and then lastly, don't forget to write this. So meaning turn this, no, not turn this. Write the formula or the equation next to the line, okay? That's just good practice because when we graph 2 lines on the same graph, that's gonna come in handy. Okay, all right, now, what's the second reason for doing this? The second reason is sometimes you have to turn this, all right, and the regions want you to do this, is to convert this into slope intercept form. So let me give you both examples, okay? So 2x plus 3y equals 12. So this is what I mean. So here we got this, right? Now, what's the slope intercept form, right? It's this. So let's try it. Now, this is why, remember that for like a month, I gave you guys literal equations for the do now, right? This is why. Because now we have to solve for y, right? So let me use a highlighter. I want to solve for y. So now I gotta do that, all right? So how do I solve for y here? What do I do? Yeah, I subtract 2x first, right? You see how all this is coming together now? So this is 3y, and then I'm going to rewrite this where the x comes first. So I'm not going to write 12 minus 2x. I'm going to write negative 2x. Positive 12 means plus 12, right? Now, we're not done yet. I want just y. I don't want 3y. So what do? Divide both sides by 3. Got that? And then we got y equals to negative 2/3 x plus 4. And that's it. That's the second reason why we have to do that. Sometimes, and you'll see what those situations are, sometimes we just need to be able to turn standard form, right? Standard form into slope intercept form. Now, why does this help, right? Think about that. Two reasons. One is it's easier for you to see what the slope is and what the y-intercept is, right? Because this is slope and this is the y-intercept. The second reason is you can't really, you could, but it's a lot of work to put this into a graphing calculator. Whereas if you use, and you'll see again later on in the week, it's way easier to put this form in a TI-84 because TI-84s, they're practically built to put this form in, and it's a lot easier to graph it like that. Meaning, right? Later on, maybe if the numbers, I mean, of course, as an example, I picked these like nice, rounded whole numbers, right? Same here, right? With this particular example. What happens if they're not, right? So that would be a lot tougher to graph something in a very quick and dirty manner, right? Like so, okay? Whereas if you, let's say you get a standard form question that isn't as nice and easy, right, with integers as x and y intercepts, you could technically turn these questions into a slope intercept form and then just put it in the graphing calculator, get the table of values from the graphing calculator, and then just graph it on the calculator. Okay, so it's a lot of things happening at the same time. Now, that said, why don't you guys try this question with turning this into slope intercept form? So right now, let me make this bigger. All right, so go ahead, press pause, and turn this question into a slope intercept form right now. So press pause right now. Okay, all right, and we're back. So here we go. All right, there it is. Okay, so again, let me wrap this up before you guys come back to class. Okay, I'm assuming we're still doing this remote because I'm actually doing this on like a Sunday before Thanksgiving. So assuming that we're still remote when we come back from Thanksgiving, all right, this is what I want to cover today. So let me summarize real quick because this is getting long already, right? What's the standard form? AX plus BY equals to C, where A, B, and C are actual numbers. Why do you need to know the standard form? Two reasons. For graphing purposes, to look for the Y-intercept and the X-intercept, or sometimes what the regions want you to do is to turn it into a slope intercept form. Okay, and that's what they want you to do. Okay, all right, so come back to class right now, and we will do some practice together. Okay, so, all right. Thanks for watching. Any questions, feel free to ask me or come to after school. Okay? All right. Talk to you later. Bye.
OMG, that was so good.